Good morning, students. We have finished, up to now, we have finished work and three types of work. These three types of works are positive work, negative work, and zero work. And this formula also we have finished, that work is equal to force into displacement. Then now today we will do start with this question, example 11.2. It is given in your NCERT book at page number 148. So see what is this question. A porter lift a luggage of 15 kg from ground and put it on his head 1.5 meter above the ground. Calculate the work done by him on the luggage. This is the question. So see, the answer is also given. Work done is equal to force into displacement, but force is equal to, here force is not given, here mass is given. A luggage is there, suppose this luggage. So he put it from ground to his head. The mass of this is 15 kg, and we know if its mass m is 15 kg, then force of gravity downward is mass into acceleration due to gravity mg. So its force downward direction is mg. So here it is written mg into displacement is 1.5 meter, because he lift it 1.5 meter up to his head. If we multiply, we will get 225 newtons meter, that is 225 joule. So this is the answer. But after lifting it, see, the luggage was here on the ground. The luggage was, this is that porter, he lift this luggage on his head. So he is doing work by lifting it from here to there. But when it will move, after that, when it will move in the horizontal direction, any direction, he will do no work, because in that case force will be this and direction of displacement will be this. It will be an example of zero work. We will say in scientific in the science definition that he is not doing any work. Now next topic that will come is energy. This question also you try to solve. Next topic will come energy. This we know energy, that different types of energy is there: solar energy, electrical energy, chemical energy, mechanical energy, and nuclear energy. These all are the types of energy. So in the form of work, how to define this energy, this all we will know in this topic. So you read these all that is written here. It is written here that the sun is the biggest source of energy for us. That all is given here. So you read every line of these two three paragraphs. Now I will be explaining this energy from the notes. From here, energy, and you see this in text question or solution of that in text question is also given here. So what is energy? Energy definition is written here. Energy of the body is defined as its capacity to do work. So energy of a body is its ability to do work. If a body can do, if anything living or non-living can do some work, we can say that that body is having some energy. Suppose we put one is suppose this metal block here at a certain height, and here we place one glass sheet. If we leave this stone or whatever it is, metal block, if we leave it from here, it will hit this and it will break that glass sheet. It means it is doing work, because it is not possible by any body to break the glass sheet without having energy. It means this body that is placed at a certain height is having energy. This type of energy that is due to rest is known as potential energy. So it is having a energy, this I want to tell you. So energy, next is unit of energy. Energy is measured in terms of work, and unit of work is joule. So unit of energy is also joule. 1 joule of energy is required to do 1 joule of work. Then there are different forms of energy. We live in a world where we have energy in many different forms. Some important forms of energy are mechanical energy, chemical energy, light energy, heat energy, electrical energy, nuclear energy, and sound energy. Then mechanical energy, this is in our syllabus. Mechanical energy used the energy used to displace a body or to change the position of a body or to deform the body is known as mechanical energy. Deform means, suppose there, so three condition is coming here. The energy to displace a body, suppose this is a body, if we can displace it, we will say we are having energy. If we can change its position in any direction, we can say we are having energy. Or if we can deform it, means if it is cuboid, if we can make it a sphere, we can say that we have energy. This type of energy is known as mechanical energy, that is required to do mechanical work. So mechanical energy is of two types. One is kinetic energy, other is potential energy. Kinetic energy is first one. The energy possessed by an object due to its motion is called kinetic energy. So the same example I'll give here. Suppose this is a glass sheet. You want to break it without touching it. So you should have one. Suppose this metal block. If you throw this block, it will go with a certain velocity. You are not going to touch this glass sheet, but this body that is coming with v velocity can break this glass when it will hit this. Why this is happening? Because this body is having an energy that is due to its velocity. This energy is known as kinetic energy. So kinetic energy of an object increases with its speed. If speed is more, energy will be more. Kinetic energy of an object moving with a velocity is equal to work done on it to make it acquire that energy. So example 1 of kinetic energy is kinetic energy of hammer is used to drive a nail into the wall. Next is bullet fired from a gun can penetrate into a target due to its kinetic energy. So these all are the example of kinetic energy. Now we will find expression for kinetic energy. So suppose let us consider a body of mass m is moving with an initial velocity v. If it is brought to rest by applying a retarding force, this is moving with energy velocity v, we have to apply a force, opposing force, to stop it, and then it will come to rest, this ball. Suppose that force is F, then it come to rest by a displacement S. Suppose the displacement before it come to rest is S. It is written here, see. And suppose kinetic energy is Ek. We know kinetic energy is nothing but work. So Ek is equal to work. We know work is force into displacement. So F into S. So let initial velocity is U, final velocity is v. Initial velocity u is, as we consider here, is considered by us is v, and final velocity v is equal to 0. So from which equation? From third equation of motion, v square is equal to u square plus 2as. Final is 0 is equal to v square plus 2as. So 2as is equal to v square, or s is equal to v square by 2. This we will get. See here, s is equal to v square by 2. So this, the value of s, if we put in that equation of energy is equal to F into S, means this equation if we put this value of S, we will get kinetic energy Ek is equal to F is nothing but mass into acceleration, and S is V square upon 2A. This here you see. So A will cancel with A, we will get Ek is equal to half mv square. So this is the formula for kinetic energy. Ek is equal to half mv square. Remember one more thing, that kinetic energy of a moving object is defined as half the product of mass of the object and square of the speed of the object, means the same thing in the written form. So work done, this question will also come later, that work done is equal to change in its kinetic energy. Actually this is known as work energy theorem. Many times we can solve numerical question by using this theorem. According to this, work done by an object, moving object, is equal to change in its kinetic energy. So W is equal to delta K, where delta Ek whatever. So W is equal to half mv square, means final kinetic energy, minus half mv square means initial kinetic energy. So this also you should know. So up to here only we are doing, up to here only. So only this much for today. Write these all topics in your copy. Okay, thank you.